Imagine the first time a hand-thrown stone left a hunter's grip and struck a mammoth at the edge of sight. That single arc turned a desperate chase into a calculated strike, and it set humanity on a path that would never stop trying to decide who controls the space between us. What does that moment make you feel? Let me know in the comments. From that primal spark, distance became the ultimate battlefield. It was not merely a measure of how far a projectile could travel. It was a shield against danger, a lever for hunting efficiency, a line that separated city walls from invading armies, and a lever of political power. When a tribe could bring down a beast without stepping into its crushing jaws, it gained food, prestige, and the confidence to expand its range. When a city could rain arrows over a fortified gate, it could dictate terms without ever breaching the stone. Each leap in range rewrote the social contract, reshaping hierarchies, economies, and the very definition of warfare. Our journey begins where the earth itself keeps its secrets. In the mist-shrouded riverbanks of Skåningen, Germany, archaeologists uncovered a cache of wooden spears, each weighing roughly 300 grams, their shafts fire-hardened to a glossy black. These are not mere sticks. They are the result of deliberate heat treatment, a technique that would disappear for millennia. The hunters who wielded them understood the physics of balance. A forward-placed center of mass ensured a stable flight, while a tapered tip reduced drag. By mastering these principles, they could launch a projectile that pierced the hide of a woolly rhinoceros from a distance that kept them out of reach of the animal's massive horn. The consequence was profound. No longer did a single hunter have to gamble his life in a face-to-face struggle. Groups could coordinate, assigning some members to drive prey into a funnel while others loosed spears from safety. This division of labor birthed the first specialist roles: engineers of the hunt, craftsmen who refined the hafting process, and strategists who mapped the terrain. The ability to strike from afar also introduced a new social currency. The skill to produce reliable ranged weapons became a source of status, laying the groundwork for early forms of trade and apprenticeship. Fast forward to the Bronze Age plains of the Near East, where the clash at Kadesh around 1274 BC pitted Egyptian chariots against Hittite forces armed with bronze-tipped arrows. The Hittites had solved a different problem. Fortified cities demanded a way to breach walls without exposing infantry to a hail of spears. Bronze, an alloy of copper and tin, offered a hardness that stone could not match, allowing arrowheads to retain shape upon impact and pierce armor that previously turned wooden points to splinters. State workshops standardized the mass of each arrowhead at roughly 20 grams, ensuring consistent flight characteristics and simplifying mass production. This standardization was a paradigm shift. Armies could now be equipped en masse, reducing reliance on levied peasants who brought their own makeshift weapons. Professional archers emerged, trained from youth to draw a bow with the force comparable to a horse's gallop. The logistical chain transformed. Metalworkers learned to cast bronze in molds that could be reproduced across the empire, and supply lines adapted to transport thousands of identical shafts to the front. The result was a battlefield where distance was no longer a gamble but a calculated advantage, allowing empires to project power far beyond their borders. If this is blowing your mind, hit subscribe and let's keep exploring together. The bronze arrow also altered the political landscape. City-states that could field disciplined archers found themselves able to enforce tribute without laying siege, reshaping the balance of power across the Fertile Crescent. Meanwhile, the very act of mass-producing bronze weapons spurred advances in mining, as societies sought reliable sources of tin, a metal as rare as it was essential. Trade routes stretched from the Anatolian highlands to the mines of the Iberian Peninsula, linking distant cultures through a shared dependence on a single alloy. In this way, a single innovation in projectile design rippled outward, forging economic ties that would endure for centuries. Our next leap arrives not on the battlefield but in the workshop of a forgotten engineer named Li Shizhen, who lived during the early Tang dynasty. Confronted with the limitations of wooden crossbows, susceptibility to weather, inconsistent draw weight, Li introduced a composite lamination of horn, bamboo, and sinew. This horn-bamboo sinew construction stored energy more efficiently, delivering a bolt with a velocity that could pierce the iron armor of a cavalryman at a range previously thought impossible. The design also allowed for a smaller, more portable weapon, democratizing access to high-powered ranged fire. The social impact was immediate. Peasant militias, previously relegated to melee weapons, could now field crossbows capable of challenging elite cavalry. This shift eroded the monopoly of the aristocratic horsemen, contributing to a gradual redistribution of military power. Moreover, the manufacturing process required skilled artisans who could source and treat each material with precision, fostering a new class of craftsmen whose expertise was prized across the empire. The ripple effect extended to trade. Horn from the steppes, bamboo from the south, and sinew from distant pastoralists became commodities in a network that linked the empire's farthest reaches. Each of these moments, fire-hardened spears, bronze arrows, composite crossbows, answers the same fundamental question. What permanent change did the innovation create? The answer lies not in the metal or wood themselves, but in the new possibilities they unlocked. They reshaped how societies organized labor, how economies prioritized resources, how political entities projected power, and how ordinary individuals perceived their own agency in the face of danger. Smash that like if this resonated, and stay with me as we trace the next great transformation, how the invention of gunpowder turned the very concept of distance into a force of nature itself. The next great transformation arrives not on the battlefield, but in the alchemical workshops of ancient China, where seekers of eternal life stumbled upon a volatile mixture that would forever alter the balance of power. In the 9th century, Taoist practitioners combined saltpeter, charcoal, and sulfur in precise proportions, hoping to create a potion of immortality. Instead, the resulting powder ignited with a thunderous roar, birthing a new kind of force that could bridge the gap between man and distant target in a single flash. The earliest military applications were modest: fire lances, bamboo tubes that spewed flame, and shrapnel, used by Song dynasty infantry to disrupt tightly packed enemy formations. Though crude, these weapons forced commanders to rethink the geometry of the battlefield. No longer could a shield wall rely solely on close-quarters defense. The mere threat of a sudden blaze demanded wider spacing and new tactics. The psychological shock of a sudden inferno also broke the morale of troops accustomed to the predictable rhythm of spear and bow. A surprising revelation emerges from the ruins of the city of Hangzhou, where archaeologists uncovered a ceramic container bearing the inscription, "Thunder Crash Bomb." Radiocarbon dating places the artifact in the 12th century, making it one of the earliest known explosive devices. Its design, an iron shell packed with gunpowder and shrapnel, demonstrates a sophisticated understanding of containment and directional force, concepts that would later underpin cannon engineering. The spread of gunpowder beyond China was not a simple diffusion but a series of independent adaptations driven by distinct pressures. In the 13th century, the Mongol hordes, famed for their mobility, encountered Chinese siege engineers employing trebuchets loaded with gunpowder-filled barrels. Recognizing the potential to breach fortified walls without prolonged battering, the Mongols incorporated these explosive projectiles into their own arsenal, accelerating the fall of cities that had previously withstood centuries of assault. When the technology reached the Islamic world, it encountered a culture already adept at metallurgy and siegecraft. The Mamluk Sultanate, facing the threat of crusader fleets, commissioned engineers to mount gunpowder cannons on naval vessels. The resulting bombard ships could unleash a barrage of iron shot that shattered wooden hulls at ranges previously unimaginable. This naval innovation forced Mediterranean powers to redesign their shipbuilding strategies, emphasizing thicker hulls and the development of early forms of armored plating. In Europe, the adoption of gunpowder sparked a profound social shift. Prior to firearms, the effectiveness of a warrior depended heavily on years of training with the sword or the bow. The Matchlock musket, emerging in the 15th century, reduced the skill threshold required to deliver lethal force. A peasant conscript, once relegated to the role of a laborer, could now stand shoulder to shoulder with a knight, wielding a weapon capable of piercing armor at a distance. This democratization of violence eroded the monopoly of the aristocratic cavalry, reshaping feudal hierarchies and paving the way for standing national armies. One of the most compelling human stories of this era belongs to a modest gunsmith named Hans Loeffler, who worked in a cramped workshop in the free imperial city of Nuremberg. Faced with the demand for more reliable firearms, Loeffler experimented with a new breech-loading mechanism that allowed a soldier to reload without exposing his hands to the flash of the match. Though his design never achieved mass production, it inspired a generation of engineers who would later perfect the cartridge system, illustrating how incremental tinkering in a single workshop could ripple outward to transform entire military doctrines. The engineering breakthrough that truly redefined distance came with the invention of the cannon. Early cannons were massive, cumbersome iron or bronze tubes that required teams of oxen to move. Their sheer size limited mobility, but their destructive power was undeniable. When the Ottoman Empire deployed massive cannons during the siege of Constantinople in the 15th century, the walls that had withstood centuries of assault finally crumbled. The fall of the city sent shockwaves through Europe, demonstrating that static fortifications could no longer guarantee security. Architects responded by designing star forts with angled bastions, a geometric solution that forced attackers to engage at multiple distances, thereby extending the defensive perimeter and reshaping urban planning for generations. A lesser-known but equally transformative development occurred in the high-altitude deserts of the Indian subcontinent, where the Maratha Empire employed a lightweight, mobile artillery piece known as the pistol cannon. Crafted from a blend of brass and steel, these weapons could be disassembled, carried by a single horse, and reassembled on the battlefield within minutes. Their rapid deployment allowed Maratha commanders to execute hit-and-run tactics against larger, slower European forces, illustrating how material innovation could compensate for numerical inferiority. The 19th century ushered in the era of rifled barrels and breech-loading cartridges, innovations that dramatically increased accuracy and rate of fire. The American Civil War, fought on a continent divided by ideology, became a laboratory for these technologies. The introduction of the mini-ball, a conical projectile that expanded to engage the rifling grooves, extended effective range to several hundred yards, turning open fields into lethal zones where infantry could engage the enemy before visual contact. This shift forced commanders to abandon traditional linear formations in favor of dispersed skirmish lines, a tactical evolution that would echo into the 20th century. Amidst these technical advances, a quiet revolution unfolded in the factories of the industrial heartland. The development of interchangeable parts, championed by a visionary named Eli Whitney, transformed weapon production from artisanal craft to assembly line efficiency. By standardizing components, factories could produce muskets at unprecedented speed, supplying armies with uniform arms and reducing logistical burdens. This manufacturing breakthrough not only accelerated the pace of warfare but also laid the groundwork for modern mass production, influencing everything from automobiles to consumer electronics. The 20th century witnessed the convergence of chemistry, physics, and engineering into a new class of weapons that could project force across continents. The first practical rockets, developed by the German engineer Wernher von Braun during the interwar period, harnessed the explosive power of liquid propellant gunpowder to achieve sustained thrust. When the Allies witnessed the launch of the V-2 rocket over London, they realized that distance had become a weapon in its own right, an unmanned projectile capable of striking targets thousands of miles away without a single soldier crossing the front line. The strategic implications of this capability were profound. Nations no longer needed to maintain large standing armies to project power. A single launch site could deliver devastation across oceans. This shift prompted the emergence of a new geopolitical paradigm: deterrence through the threat of mutually assured destruction. The Cold War's nuclear standoff, anchored by intercontinental ballistic missiles, turned the concept of distance into a perpetual, invisible shield that dictated international relations for decades. Yet the story of distance does not end with the atom. In the late 20th century, engineers refined guidance systems, integrating gyroscopes, inertial navigation, and satellite positioning to create precision-guided munitions. A missile could now adjust its trajectory mid-flight, striking a specific window on a building with surgical accuracy. This precision altered the calculus of warfare, allowing limited engagements that minimized collateral damage while achieving strategic objectives. It also raised ethical questions about the role of technology in shaping the morality of conflict. A surprising footnote to this evolution lies in the realm of space exploration. The same rockets that once delivered warheads to distant cities now carry scientific instruments beyond Earth's atmosphere. The International Space Station, orbiting high above the planet, serves as a laboratory where engineers test new propulsion technologies that could one day enable rapid, low-cost delivery of supplies across the globe. In this sense, the quest to control distance has come full circle, from hunting megafauna on the plains to delivering knowledge to the stars. Throughout this journey, the human element remains the constant driver. The alchemist who mixed powders in search of immortality, the blacksmith who forged the first cannon, the farmer-turned-soldier who lifted a musket, the engineer who imagined a guided missile, all faced the same fundamental problem: how to extend their influence beyond the reach of their own bodies. Each breakthrough did not merely add a new tool to the arsenal. It reshaped societies, economies, and the very way humans perceive power. When the first fire-hardened spears allowed hunters to bring down mammoths without risking their own lives, they sparked the emergence of coordinated groups, laying the groundwork for complex social structures. Bronze arrows enabled city-states to defend walls and project authority over surrounding lands, fostering the rise of organized armies and bureaucratic governance. Composite crossbows democratized lethal force, eroding the dominance of mounted elites and prompting new forms of civic participation. Gunpowder shattered the sanctity of fortifications, accelerated the decline of feudalism, and birthed the modern nation-state. Rifled firearms and interchangeable parts accelerated industrialization, linking warfare to the engines of economic growth. Rockets turned distance into a strategic variable that could be measured in minutes rather than months, redefining global politics. The story of humanity's quest to master the space between us is, at its core, a story of adaptation. Each innovation emerged because the previous methods could no longer meet the demands of survival, expansion, or security. The weapons themselves were merely vessels. The true legacy lies in the new possibilities they unlocked: new social orders, new economic networks, new political ideologies, and new ethical dilemmas. As we look toward the horizon, the next chapter may be written not in steel or powder, but in photons and quantum fields. Yet the underlying question remains unchanged. How will we choose to control the distance that separates us, and what will that choice mean for the future of civilization? When the first fire-hardened spears allowed hunters to bring down mammoths without risking their own lives, they sparked the emergence of coordinated groups, laying the groundwork for complex social structures. Bronze arrows tipped with alloyed points enabled city-states to defend walls and project authority over surrounding lands, fostering the rise of organized armies and bureaucratic governance. Composite crossbows democratized lethal force, eroding the dominance of mounted elites and prompting new forms of civic participation. Gunpowder shattered the sanctity of fortifications, accelerated the decline of feudalism, and birthed the modern nation-state. Rifled firearms and interchangeable parts accelerated industrialization, linking warfare to the engines of economic growth. Rockets turned distance into a strategic variable that could be measured in minutes rather than months, redefining global politics. Each breakthrough did not merely add a new tool to the arsenal. It reshaped societies, economies, and the very way humans perceive power. The story of humanity's quest to master the space between us is, at its core, a story of adaptation. Every innovation emerged because the previous methods could no longer meet the demands of survival, expansion, or security. The weapons themselves were merely vessels. The true legacy lies in the new possibilities they unlocked: new social orders, new economic networks, new political ideologies, and new ethical dilemmas. As we look toward the horizon, the next chapter may be written not in steel or powder, but in photons and quantum fields. Yet the underlying question remains unchanged. How will we choose to control the distance that separates us, and what will that choice mean for the future of civilization?